So we are starting to answer questions on the practice test for Unit 1. Unit 1 test will be on the 9th of February, so it's still a couple of 2 weeks plus, so we still have time, but it doesn't hurt to start. Okay, I hope everyone is doing well. So, but let's see if we understood chapters 1 and 2. It says a dash is a person or object that is a member of a population being studied. Any member of a population being studied is this statistic? No. Is it a parameter? No. Is it an individual? Yes. A member of the population being studied is an individual. Even if you are studying tables, one of the tables is an individual. Whatever you're studying, a member of that that sample is called an individual. All right, so I just want to make sure. See, it's one question. It's actually one question. Okay. Determine whether the variable is qualitative or quantitative. Determine whether the variable is a qualitative or, but before we go to find whether, I'm going to define qualitative. Remember that if a variable is qualitative, qualitative, it's also categorical. So it's in categories. A qualitative variable is also categorical. So they're in categories. And which it also means that the actual definition is that arithmetic does not make sense. They're in categories. Arithmetic does not make sense. An example is hair color: green, yellow, black, orange. So these colors, if I add green plus yellow plus orange, I won't be able to add it. So that is called a qualitative variable. That kind of variable is called qualitative. Okay, arithmetic doesn't make sense. Or even if it has numbers. For example, if your zip code is 2905 55, and another person has 39022, and another person has 29662. I'm going to stop here. So if three people have, they have maybe different zip codes. If you add them up, these zip codes, if you add them up and divide them by 3, that means find the average. The average can be a decimal. And by the way, a zip code is not supposed to be a decimal. But even if the decimal matters, whose zip code will be the average? So that's what I'm saying. If addition and subtraction make sense, then it's a quantitative variable. So a variable can be quantitative when arithmetic makes sense. So remember, we were doing mean, median, and mode. So for you to find the mean, the median, and the mode, arithmetic will make sense. It's a quantitative variable. All right, so we have already seen some examples of quantitative variables where we found the 5 numbers summary. I'm saying it again because the first day I said it, nobody was in class. But if it is quantitative, arithmetic makes sense. It's qualitative, arithmetic does not make sense. Examples of qualitative are zip codes, hair color, a lot of examples. There are graphs of qualitative variables. You can draw a pie chart for qualitative variable, pie chart. You can draw a bar graph. Bar graphs don't touch. So bar graphs are for qualitative variable. And others are dot plot. But if the variables are quantitative, and by the way, if a variable is quantitative, it can be continuous, discrete, or continuous. Discrete. So a quantitative variable can be discrete or continuous. So discrete. So discrete or continuous. Continuous. And what does discrete mean? If a variable is discrete, it's countable, can only count it 1, 2, they are integers. They are whole numbers. Whole numbers. So you can 0 is countable. They are, but if it is 5.1, then it's not discrete. If it has a decimal, it's not discrete. All right. Continuous. In other words, a quantitative variable can be discrete or continuous. But whether discrete or continuous, they are all quantitative. Arithmetic still makes sense. Arithmetic still makes sense. So a discrete variable is quantitative. Continuous variable is quantitative. So what is continuous? A continuous variable must be measurable. It can have decimals. If a variable is continuous, it is measurable. Arithmetic makes sense. Discrete, measurable, arithmetic makes sense. Okay, so when a variable is discrete, it is continuous. I mean, if it's discrete, it's quantitative. It is continuous, it's quantitative also. If a variable is qualitative, it's categorical. The kinds of bar graphs you draw is bar graph and pie chart. Okay, let me try to clean. Try and clean this and see how it goes. So let me try and clean up that. All right, so you are not cleaning. Okay, so I can move this up then. So you'll be able to find which one is discrete and which one is continuous. Okay. Volume of liquid is continuous because if you measure it, it can be 50.3 cubic feet or cubic whatever, cubic inches. Water, if you are measuring water, it's measurable. First of all, it's continuous. It is quantitative. Okay, so the next thing we want to do is the sampling methods, which we have read already. I told you to read that, but that's one I want to talk about because we use it a lot. So the one I want to talk about is systematic sampling method. The systematic sampling method. If a sampling method is systematic, then you are taking every kth number. So suppose I want to count 5 people from 100 people. So I will start 1, 2, 3, 4, 5. The 5th person comes out. Then I start again 1, 2, 3, 4, 5. When I get to 10, another person comes out. When I get to 15, another person comes out. When I count person number 20, another person comes out. When I count person number 25, and so when I finish, I collected the kth person. The 25th person it's going to be the 5th. So now I selected the sample according to systematic sampling method. Then I can do some variables, I can make sure that I apply a systematic sampling method, simple random sample, to take a sample, make sure that that the sampling that I'm using will be to pick this up. Okay, so there are 5 of them that I want you to read. I told you to read, but I wanted to make sure that we talk about systematic sampling method. The Kate, that's the one. So we shall do some calculations today. You have probably read all this. We shall come back to this. Notice that we talked about skewness yesterday. So you will be told to determine whether the following statement is true. The shape of the distribution shown is best classified as skewed left. Is this true? This is not true. The distribution is skewed right. If you look at it very well, the tail is going to the right. The tail of that distribution is going to the right. Therefore, the distribution is skewed right. Okay, that distribution is skewed right. So if I try to put a density curve on it, see that the distribution is skewed right. Remember the other day we said that if a distribution is skewed right, then the mean is greater than the median. The mean X bar is greater than the median, Q2. If a distribution is skewed right, the mean is greater than the median. Okay, and if a distribution is skewed left, the mean is less than the median. So in any skewed left distribution, the mean is less than the median. So this is skewed left. Skewed left. And this is skewed right. Skewed right. A skewed right distribution can be called positively skewed. A skewed left distribution can be called negatively skewed. So a distribution can be skewed right or skewed left. If a distribution is not skewed, we say it is normally distributed. If a distribution is not skewed, we say it is normally distributed. So a normal distribution is not skewed. Okay, I'm going to draw a normal distribution. Okay, if a distribution is skewed, it's not skewed, we say it is normally distributed. So I'm going to draw this out and see. So if a distribution is normally distributed, we say it's approximately normal. Okay, so the mean is equal to the median. The mean is equal to the median. And this mean is X bar for the sample, and the median is Q2. So when the mean is equal to the median, we say the distribution is normally distributed. Remember the skewed right distribution. In a skewed right distribution, the mean is greater than the median. In a skewed left distribution, the mean is less than the median. So here mean is less than the, here mean is greater than the median because it's skewed right. Here mean is less than the median because it's skewed left. Okay. All right, yesterday we talked about stem and leaf plots 2 days ago. So we shall actually also talk about stem and leaf plots today. So let's look at the stem and leaf plot given to us here. So we can be given a stem and leaf plot and we are told to answer questions on it. Determine the original data here. So we are given the legend. The legend says that 5-2 means it just means one. The first it means that the first one is 150, 152, 53, 155. Okay. So and here it says 5.2. So actually the first one means 15.0, 15.2, 15.3, 15.5. So this one, the digits here are all continuous. All right, so let's see what the question is saying. Choose the correct answer. So because you are given this one, this legend, you want to make sure that you choose. Okay, so we're going to look at according to the legend given to us, this A is not the answer. B is not the answer. C, let's see. The first digit is 15.0, second digit is 15.2. The third one, okay, so let's look at the last two. 19.2, so 19.2 and 19.6. So the correct answer should be C. So the correct answer is C. The correct answer is C. All right, so these questions are not difficult, and you can actually be told to find the 5-number summary of this data. You can be told to find the 5-number summary. You can be told to analyze this data. I mean, so many questions. So right here, you are given a raw data. Why did I say it's raw data? Again, it is raw data because it's not organized in ascending order or descending order. So you'll be told to arrange it in ascending order or so. But the question says find the frequency distribution or create a frequency distribution. That's what they want us to do. So let's try and do that. It's going to take a little bit of time, but let's find the frequency distribution. All right, so the frequency distribution, see, okay, all right, so from 1 to 3, so we're looking for numbers from 1 to 3. Look at the first column. There is no number 1 to 3 here. Let's look at the second column. There is no number 1 to 3 here. We are creating a frequency distribution. You see the frequencies column is empty. So column 3 has 1, 2. So 1, 2. There are only, let's see. There are only 2. Make sure I see it very well. So there are 2 numbers. So 2 numbers are between 1 and 3. But that's not all. We are going to continue counting. So 3, 4, 5, 6. So we are going to so now we put, so the number of digits between 1 and 3 is 6 according to accounting. So let's check the next one. The next one says from 4 to 5, 4 to 6. So it's not this. It's not this. 5 is between 4 and 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 of them that are from 4 to 6. Okay, now from 7 to 9, we're looking for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 numbers between 7 and 9. So let me move up a little bit. 11 of them. So I'm going to move up a little bit. So the first column is 6. All right, so I just want to make sure that this is not going to. So we have 6 here, 6, 15. And 11. I'm going to put 11 here, and I'm going to clean the other 2. So I'll take this one out, take this one out. All right, 10 to 12. So from 10 to 12, I'm going to go up to find 10 to 12. How many numbers, many digits are between 10 to 12? All of them are discrete. There is no decimal here. They're all discrete. We cannot say they are discrete. That's all we know. Okay, so now we're going to count the numbers between 10 to 12. So let's see. So we're counting from 10 to 12. All right, so by the time you finish doing that, we have already seen that the first one, we have seen the first one since. So now you will finish. When you finish, you answer the question. So what percentage of Saturdays has 7 or more? So you should be able to answer the question. By the way, before you answer that question, you should know the total. So what is the total number? The total number here, you want to know how many, by the way, because the question says the data to the right represents the number of customers writing for a table at 6 p.m. for 40 consecutive Saturdays. Complete parts A through. Okay, so we want to know, it says these are customers. So they're actually human beings. So we hear 1, 2, 3, 4, 5. If we count this is 5. This is 10, 15, 20, 25, 30, 35, 40. So the total number of customers is 40. So I can as well find the relative frequency. So if the total number of customers are 40, the relative frequency of the first class is 6 out of 40. The relative frequency of the second class is 15 out of 40. The relative frequency. So you can be told to find the frequency, then you will also be told to find the relative frequency. And you can put it here, so find the relative frequency and answer all the questions. So that is exactly the kind of things we did, kind of thing we did yesterday. Find the frequency, then find the relative frequency. Okay, so see these questions are from chapters 1 and 2. These are from chapters 1 and 2. They're all talking about quantitative variables, qualitative variables, relative frequency. Okay, so true or false, a data set will always have exactly one mode. True or false, a data set can have more than one mode. So that is false. A data set can have more than one mode. Can have 3 modes, you can have no mode. So that is false. So these are the kind of questions we have in this section. They are not difficult questions. Well, let's go to number 19. It says find the population mean. So maybe this is the only calculation or one of the calculations we are going to do. Find the population mean. So when it says find the population mean, it means add all of them. The important thing is that they told you it's population. Find the population mean. Find the population mean. So add all of them and divide by the number. So add all of them, divide by the number. And if you want to do it by hand, that's fine, algebraically. So, but I have to pull up my calculator and do it by calculator. So let me see. I'm going to put my calculator up. And I want to put the numbers in a list, even though there are not many, but it doesn't really matter. So I go to stat. The important thing is that I'm told that this is a population. So since it's a population, I want to make sure that, so 5, 9, 14, I'm putting the numbers in a list. 14, 19, 18. Okay, so I have all the numbers in a list. Then the first thing is to look at the numbers given to me, make sure that they are correct. Whenever you put the numbers in a list, you want to make sure that you put it correctly. So the next thing is find the mean. The mean is average. When you get the mean, remember that this is population mean. And when the question says population mean, it means you have to write it as a mu, not x bar. Okay, so find the mean. This is not difficult. We have done it before. Let's do it again. Go to stat, arrow to calc, do one variable stats. So one variable stat of the data I have in L1. Yes, so I'm going to calculate. Okay, so the mean is 13. I'm told that the mean is 13. So the most important thing is to be careful that you don't write that mean as x bar. So let me get so the mean is 13. Write it in the first one. You cannot write it in the second one. Why? Because you are told that it's a population. The mean of a population is mu. The Greek mu is called mu, mu. So you write it in the first one, the mean of a population, mu. Mu is 13. So it's the same calculation, but if you write the answer as 13, then your answer is wrong. If you write 13, the answer is wrong. What am I saying? I'm saying that if you write your answer in B, if you say that x bar is equal to 13, the answer is wrong. Why? Because x bar is a characteristic of a sample. So you are not given a sample, you are given a population. You are not given a sample, you are given a population. Okay. All right, so the next one is let's go to the next one. For a large sporting event, the broadcaster sold 52 ad slot for total revenue of 137 million. What was the mean price for? So how many are there for a large sporting event? Okay, so um, how many did he sell? Ad slot 57 or 56? Okay. What was the mean price? So the mean price is the 137 million divided by 56. 137 million divided by 130 uh, divided by 56 is the mean, because that's just a simple question. They gave you the amount of money, the total amount, and told you the number of ad slots. The number of ad slots is 56. Okay. For the histogram on the right, determine the mean. Determine whether the mean is greater than, less than, or approximately equal to the median. So they didn't give us any numbers. They did not give us numbers, but let's check. What am I trying to say? I'm trying to say that in the denominator, there are no numbers. So actually, how do we know the weight of the denominator? Okay. But anyway, what we can do is estimate, do an estimate. So I can superimpose the density curve here. I can superimpose the density curve on it. And if I superimpose the density curve on it, this is not perfect, but kind of okay. I'm gonna clean that. So I want to superimpose the density curve on this data and see if it's approximately, does it look approximately normal? Well, it looks like, yeah. So the density curve looks approximately normal. Yeah. So if the density curve is approximately normal, then we can say, what's the question? For the histogram on the right, determine whether the mean is greater than, less than, or approximately equal to the median. So I will say that the mean is equal to the median. Why? Because the data looks approximately normal. This is an approximation. So mean is equal to the median, assuming it's a sample. If it's a population, then I can still say mu is equal to the median. When we have a normal distribution, when the distribution is bell-shaped, then we say that the mean is equal to the median, mu equal to the median. Okay. Well, that's what we can answer in that question, because we're not given the base, the x-axis, the horizontal axis. The sum of the deviations above the mean always equal to the sum of the deviations, what did it say, above the mean, always equal to. So it depends on, if it's a normal distribution, the sum of the area, maybe area under the right is 0.5. The sum on the left is 0.5. Total area under the normal curve is 1. The question there is not clear. That question is not clear from the people last year too. So, but the total area under the normal curve is 1. If I divide the normal curve by 2, if you divide it by 2, the The area to the right is 0.5. The area to the left is 0.5. Find the sample variance and sample standard deviation. Okay, so this one is told us. This told us it's a sample, so we have to know, we already know it's a sample. The same kind of question we did before. But right now we are told it's a sample. We're talking about this now because even though we have a test in 2 weeks, because we just started this class last week, I want to make sure that we know how to calculate. There are some things we need to know how to calculate. Okay. So I'll put this data in number 23. So I'll go to Start, Edit, and I'll clear L1, put the data in L1. First of all, I am told that this data, is a sample. How a sample? I'm told to find the sample variance and sample standard deviation. So since I know it's a sample, when I collect my answer, I want to make sure that the sample variance I get should be here. The sample mean is this. Therefore, I'm looking for statistic. The sample standard deviation will be this. So let's go ahead and put the data in our calculator quickly. So the first number is 22. 22, enter. Okay, the first number is 22. Let's see. I'm going to type it in. Let me type it in my calculator. 22, enter. The second number is 16, enter. The third number is 6, enter. The fourth number is 7, enter. The other number is 11, enter. So I'm going to, the question says find the sample variance and sample standard deviation. So I'll go back and go to Start again, calculate, do one variable start. So my data is in L1. And I'm doing one variable start of this data. It's not a group data. The data is a raw data. It's not a group data. So I'm going to calculate. So the mean is 12.4, even though I'm not asked to find the mean. The sample variance is, let me see how many decimal places. Round to the nearest tenth. Right? Rounding to the nearest tenth means round to the nearest one decimal point. Okay, so sample standard deviation is 6.7. So 6.7. Sample standard deviation is 6.7. Sample variance. So I can multiply and you don't have to round it up. So what I'm going to do, the easiest way is go to var statistics. Let me go to vars. So I'm going to go to vars statistic, which is number 5. Select sample standard deviation, which is number 3. And then I square it. Why do I want to square it? I'm looking for sample variance. Okay, standard deviation multiplied by standard deviation is variance. So I'm looking for sample variance, so 44.3. So 44.3. All right, so 44.3 is my answer as variance. So I'll just put it here. Totally my answer to the nearest 10, 44. And then put the other one, put the answer there. Important thing is that you understand the question is a sample. So they want to know if you know that the characteristics of a sample are called statistic. And so if this is sample, then the mean is X bar. The mean is X bar. The standard deviation is S. The variance. So standard deviation is S. Variance, and you can use S sub X. Variance is X sub X squared. But if it is a population, the mean is mu, the Greek mu. The standard deviation of a population is sigma. The variance of a population is sigma squared. Okay, so that's actually what they want to make sure you know. They want to make sure you know that the characteristics of a population is called parameter. Let me write it here, parameter. Want to differentiate parameter from statistics. The characteristics of a population is parameter. The characteristics of a sample is statistic. And when you are told that data is a sample, then you should be able to find all the missing, all the numbers. When you're told that the data is a population, then you should be finding all the parameters. So characteristics of a sample is statistic, not the same as statistics as the subject. It is statistic. The characteristics of a population is called parameter. Okay. All right, so we are going down to, let's see more questions on this one practice test. More questions on this unit one practice test. Okay. The mean, this is also mean. So these are all mean. All right. Okay. Use the empirical. No, so we haven't done empirical rule. We're going to do empirical rule next week. And when we do empirical rule, then, but what we have done is group data. So we will make sure we do number 26. We have done group data. But this group data is horizontal. So you have to be very careful when you're given a group data and the group data is horizontal. I always want to put the horizontal group data. I want to make it vertical. So I want to rewrite it to look vertical. Okay, this way. All right, so so now I want to rewrite that to be vertical. In other words, I want to write the frequency distribution to be vertical so that age will be the first column, number in millions. Number in millions. Millions will be the second column. So then I will extend this column. And how many classes do I have? 1, 2, 3, 4 classes. All right, so the ages started from 25 to 34. 25 to 34. The number in million is 21.8. So 21.8 million people were aged between 25 to 34. 35 to 44 people were aged between 37.5. 37 to 44 years as 37.5 million people. Okay. Now we have the next column. Next column is 45 to 54. 45 to 54. We are aged between, those who are aged between 45 to 54 are 36.7 million. 36.7 million. And those who were aged between 55 to 64, they were 20.7 million. 20.7 million, 55 to 64. 55 to 64. And that is 20.7 million. Okay. So what is the total number of people there? The first thing you want to find out is how many people were there. They give you the answer in decimal, so you might want to. So you want to get your calculator and find what is the total frequency? How many people were there? What is the total frequency? We can add all this together and find the total frequency. So the total frequency is 21.8 plus 37.5 plus 36.7 plus 20.7. All right, so the total number of people who were there are 106.7. So the total number is 106.7, 116. So 116.7 is total frequency. Let me write it here. Total frequency, 116.7. All right, and then suppose you're told to find the relative frequency. What is the relative frequency, or what is the probability that if you pick somebody at random from that group, the person is aged between 25 and 34. So that would be 21.8 divided by 116.7. And you could be told to leave your answer in percent, decimal, or fraction. What is the probability, or what is the relative frequency? We said that relative frequency is the same as probability. I keep saying that because people forget. What is the probability that you pick somebody at random in that population and the person is aged between 35 and 44? So the probability is 37.5 divided by 116.7. So what is the probability that if you pick someone at random in that community, person is aged between 45 and 54, it is 36.7 divided by 116.7. So what is the probability that if you pick someone at random between 55 and 61, that person, or the person is aged between 55 and 61. So if you pick someone at random, that probability is the frequency of the class, the total number of people on that in that class all over the total frequency. And then you can actually find them in. So the class is almost over today. What we're going to do is next class we shall start with this number. We shall find the class midpoint of this. We shall also find the cumulative relative frequency. We shall find everything about group data. We already started group data, but I want to make sure that you know there is going to be real world problems in that question. There will be real world problems in that question. Okay. There will be real world problems in question. All right. All right. So I am going to stop so far. I don't know if I see anybody coming now to stop recording.